In continuation with the previous two videos for module 1 and 2, there I discussed the important questions regarding the theory as well as the numericals. So in this video, we'll be discussing the important questions regarding module 3. Okay, so there are totally 6 questions which are important from module 3, and some of them are super important, like this one, this one, this one, this one, and this one. Okay, so openGL illumination functions, it was not much repeated, so I did not include that in super important. But the flow of this video will be as follows. Firstly, we will be discussing this question, then we will be coming to this question and this one and this one. Okay, and finally after that is done, we will go to Cohen Sutherland, and then Sutherland Polygon clipping algorithm and numerical. Then we will be seeing the 3D transformation functions, categories, and numericals. Actually, the numericals are not asked in any of the single papers, so I will not be discussing that. I will be just discussing what is the matrix values and the transformations that happen in 3D geometry. Okay, so let's get started with the first question, which is explain viewing coordinate clipping window, world coordinate clipping window. There are two questions which are asked here: viewing coordinate as well as the world coordinate clipping window, and normalization as well as the viewport transformation for viewing as well as the world coordinate, and write the matrix vector for the same. Okay, so let's see what all we have to write, and there are actually a lot of content to write in that. So we'll be just seeing briefly over the overview of what it is and what it means. Okay, so the clipping window, what is a clipping window? If you have a bigger picture, you will be clipping it into a smaller picture here, that is known as a clipping window. Viewing coordinate clipping window, this is the world coordinate, and inside that what you clip is the viewing coordinate. Okay, so basically that's all what you have to write here, and actually there is a lot of content here, and the main thing what I told you is that the difference between the world coordinate and the viewing coordinate. There is a top surface which is called the world coordinate, and inside that is the viewing coordinate. Now if you have transformed into a viewing coordinate, you can do the translation as well as the rotation. This is the rotation operation, and this is the translation operation. So you can make this graph and write a few words regarding that. Okay, and if you can remember, it's very much recommended that you write the matrix values also. So the matrix values will be here in the normalization and viewport transformation. In normalization and viewport transformation, there are two matrix values. This for the normalized mapping. See here, mapping the window to a normalized viewport. Okay, so we are normalizing the viewport from a clipping window to a normalized viewport, and if you can remember these equations as well as the matrix values, these three matrix values, scaling and the translation, and translation scaling together, if you can write this one, you will be means you can expect more marks rather than missing that. Okay, and mapping the clipping window to a normalized square. Okay, this is another one, and here is the diagram for it. You will be clipping this window to a normalized square, and then transforming it into a screen viewport. Basically, we are normalizing it here, both the viewing window as well as the world window. Okay, and these are the matrix values. Mostly if they see the matrix values, they can easily give you marks. Okay, because there's the relevant concept here. And this is the diagram which you have to make, like it depicts what is the total screen width and all, and what is the scaling applied, and what is the diagram, and where is the viewport defined. Those things will be shown in this diagram. So if you write make this diagram and write some relevant concept regarding that, that is also recommended. Okay, so that was about the viewing coordinate window and the world coordinate clipping window transformation as well as the vector matrix. Let's move on to the next question, which is different point sources, light point sources. There are two questions here: light point sources are different light point sources as well as the basic illumination models. It's presented page number 30 and 35. So these are the two separate questions which could be asked. Either they can ask you regarding the different light sources, or they can ask you the different illumination models. Okay, so it comes in the illumination model only. Illumination model is nothing but lighting model. How do you light an object from different perspectives? So the light sources, mainly there are 4 light sources. The first light source is the point light source. Here's some extra information, you can go through it, but the main point is the point light source. In point light source, it radiates equally in all the directions. Okay, from a point source. Second is the infinitely distant light source. Here the light source comes from a far distance like sun, and that is the lines are considered as parallel. The third one is this is the attenuation. This is the subtopic. Either you can go through it or skip it. Directional light sources. In directional light sources, you will have one particular direction in which the light source is defined. So it will be radiating in the angular form, means in the cone form, and the object will be lighted accordingly. Where the light form comes, there it will be lighted. Where it is not coming, it will be left as dark. That is called as directional light source. The next one is and there is angular intensity attenuation in the directed light source, as it was in the infinitely distant light source, there was radial attenuation. In the same way, angular attenuation will be there in the directional light source. The last one is the extended light source or the WAN model. Here we will be having extended light source for all the places where it is to be lighted. So some of the techniques which can be used is wherever the light source is defined, it will be brightened up, and the remaining places where the extended light source is not defined, it will be darkened. And it can produce the studio effects, as it's mentioned here. The one model can be used for producing the studio light effects, okay, using the set of point emitters and various parameters. So those are the basic key points you have to write for the 4 things: distant, the point light source, the distant light source, and the direction light source and extended light source. Okay, those are the 4 light sources. If they ask you about the illumination models, there are the illumination models are ambient light. Ambient light means it produces a uniform lighting for all the objects. Okay, and diffuse reflection means it will be diffused in all the directions. Okay, and some more information is given, but that's the key point. And don't try to get into the details of it, because it's a lot of content and the time is limited. Okay, so you have to manage the time accordingly. And next is the specular reflection and the Phong model. And Phong model is asked as a separate question itself. Okay, so this is an important concept. What you have to keep in mind is these 4 vector values: L vector, N vector, R vector, and V vector. N vector is the normal vector, which is coming out as a normal value, okay, from the point source. And L is the light vector, which is towards the light source. R is the reflection vector, where it is getting reflected after touching the surface. And V is the viewing vector, where you are viewing from. Okay, so these are the 4 vectors you have to write about after drawing this diagram. And there are some matrix values as well, and the equations. So if you have time, you can go through it, or else you should manage with the theory itself. And this is the shiny surface, it will be very small, the reflection. The dull surface will have a wider reflection. That's another key point which you can use, as well as you can make the graphs. So in the graphs, as the angle increases, the intensity decreases. Okay, that also you can mention, except the matrix values and all. Okay, so here are some equations, and the matrix values are there for different cases. If you have time, you can go through it, that will be better for you. Okay, next we have the openGL illumination functions. So the illumination functions are just like darkening it or lighting it, light name and property, the position where you have to do, and 3 types: ambient, diffuse, or specular, which model you are using. And for information, there are 3 illumination models: ambient model, diffuse model, and the specular model, also known as Phong model, which we just now discussed. So how to implement that in the openGL, those functions are mentioned here, so you can go through them. Okay, then what we have is the color models RGB and CMY. So what are the color models? Color models are the methods which is used for explaining the properties of behavior of color with some particular context. There is a context, and in that, what is the colors used and what are the properties of the colors, how they change according to the views, those things are defined by a model known as color model. So there are basically 2 types of models: RGB model and CMY model. Only one thing what you have to keep in mind is, in RGB model, if R, G and B all are mixed, you will get a white color. You remember in the 7th standard you had studied, if you color a paper with all the colors in a circle and then rotate it, it will be visible as white, right? So in that RGB, if you mix all, it will become as white. That's how I remember till now. Okay, so in RGB it is X, Y, Z axis. So in R you will have here, and G you will have Y axis, and blue you will have in Z axis. And the combination of red and green is nothing but yellow. The combination of red and blue is magenta. Just imagine, if you are mixing 2 colors, what color you will be expecting. Green and blue, it will produce cyan color. And if nothing is there, it will be black. Okay, so if you make this cube, that will do the half part, and the rest part you have to manage by writing about the different colors RGB. Okay, same thing goes for the CMY also. That is the reverse of RGB. Here you will have CMY, right? Cyan, magenta and yellow, and inside you will have the RGB, R, G and B. Okay, like this you will write CMY, and RGB you will write like this. In the previous one, RGB you will write like this, CMY you will write like this. Okay, and if you mix all the colors, you will get as black. If you don't mix any color, you will get as white. It's the reverse of RGB. So basically you have to explain these things. And one of the other thing you can include is, if you add those 2 colors, you will get as 1. If you subtract 1 from RGB, you will get CMY. If you subtract 1 from CMY, you will get as RGB. Okay, so these are the concepts which you can write, and it's a pretty important question, so don't miss it. Now let's move on to the things which we skipped, which is Cohen, Sutherland, Polygon, and the numerical as well as the algorithm. Then we have 3D transformation functions. So let's have a look. So this is in different PDFs. So it's in clipping PDF, we'll do these two things, then we'll move to the 3D PDF. So let's move on to the clipping PDF. This is the clipping PDF which I am talking about. So here if you go to page number 17, there you can find out the Cohen Sutherland clipping. Okay, so the algorithm also like you have tried in your own words, as we had done for the general scanline algorithm. So I'll tell you the brief overview of what you are supposed to do here, then you'll be seeing the numerical. You will be given with 4 points, okay, A, B, C and D. 4 points will be given and you have to mark those 4 points as a form of rectangle or a square. Okay, after you have done that, you'll be given with further 2 points P1 and P2. Those 2 points are present here. Okay, P1 and P2, this is P1 and this is P2. After you have marked this one, you have to perform a test on it. The test is also known as what I'm talking about is this test. Okay, region codes test. Okay, you have to perform the XOR operation. So it is in the form TBRL. What is TBRL? Top, bottom, right, left. So this is what top, left, right. So top and left will be 1, rest will be 0. This is what, this is just right, nothing else. So 0 0 1 0, just right. Okay, so that's in that way it is written, and middle one will be 0 0 0 0. And this you have to write for the theory and the algorithm for the Cohen Sutherland. After you have written this one, if you get 2 points, there can be 4 cases. Either the points lie inside the square, or it can lie outside the square, or it can the points can lie outside the square but it's passing through inside, or one of the point is outside, one of the point is inside, or both the points are passing through outside. Okay, like this one only, but it's passing through 2 different region codes. So how to identify which case do the points lie? So to do that, what you have to do is for the point 1, what is this? This is left, right? Left means 0 0 0 1. P2 is also left, 0 0 0 1. After you have written the 2 codes, then you will be doing the AND operation. And if you get another the same code, that means it's a outside line. The whole line is outside. Basically, if this is non-zero and this is also non-zero, and if you get another answer as non-zero, that means the line is to be excluded, that is outside the plane. The other way, like you can get both as 0. In this case, you will get both as 0, P3 and P4. So if you do the AND operation also, you will get as 0. In that case, the line is to be considered, it is inside the plane. But in some cases, you will get both as non-zero, but the answer you will get as 0. What I mean is, the non-zero is present here and this is 0. Okay, there is non-zero here and there is 0 here, so the answer you are getting as 0. What does that mean? If non-zero and 0 means one of the point is outside, one of the point is inside, and you are getting as 0 means that is to be considered. Okay, and if you get the other one, which is, so basically what I am telling is, if you get non-zero, 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 exclude that line. If you get 0 0 0, exclude that line. If you get non-zero and 0 and the answer you get as 0, then include that line. And 0 non-zero and 0, that also include that line. So basically you just have to write this in theory, it will not be relevant in the numerical which is solved. Also the numerical is solved in a different way here that I found hard, so I'll be telling you another shortcut method which you can use to find, and that will be perfectly valid and you will get the marks for it as well. Okay, so what you have to do is, see, the points are given. Okay, your basic task is to find out this point and this point where it is getting cut. Okay, for that what you have to do, you have to take P1 point and P2 point, you have to find out the slope of it. What you have to find out? You have to find out the slope of it. After you get the slope value, then at this point it is intersecting, this point it is intersecting. At this point you know the x value, this is the x value, all you have to do is find out the y value. This is very easy. You know the slope value, you have the x value, you have to write y is equal to mx plus c. Okay, y is equal to mx plus c. So what is the y value you have to find out? You will be writing it as y only. What is the m value? M value is nothing but the slope, right? After you have substituted the slope and the value of c, you can easily get x, but in this case we don't have the value of c. Now how do we find out the value of c? Consider the point here. What we need? The y value, right? So we'll take as x comma y. X value is already known, 20, so let's take as 20 comma y. And what is this point? P1, it is given as what? P1 is given as 10 comma 30. Okay, 10 comma 30, and the next point is 20 comma y. Now if you subtract it, the slope will be same for this one as well as for the outer line also, right? Slope will be same. So if you do y2 minus y1, y minus 30 divided by 20 minus 10, that is equal to slope. Slope we already calculated. So if you find out, substitute the value of slope and cross multiply, you will easily get the value of y. Same thing you have to do here also, you will get the value of x. Just the difference is, you got the slope value anyways. Here the y value, you know, it is 70, so you will write 70 minus x divided by, what is this point, 80 comma 90, right? So see here the 2 points x, 70 minus 90 divided by x minus 80, that is equal to the slope value. Slope value calculated using these 2 points, the 2 points you known. So if you cross multiply, you will easily get the value of x. That's all what you have to do. You will get the value of coordinates of this one and this one. That's your final answer. Okay. Algorithm also you have to write in the same way. You will write stepwise 1, 2 and 3 and all. So in step 1, what you will do, firstly you will take the region codes where it is lying, the point is lying outside or inside, using XOR values as well as using the AND values. You will calculate where it is lying, which case it is. After that, the cases which you have to consider, you will mark these 2 points. You will find out the slope of it, the whole plane. After you find out the slope, you will find out the missing point here. If it is for y, you will find out for y. If it is for x, you will find out for x. After that, you will mention the cutting points where it is and the line which is obtained at the output. That's all what I have written in the algorithm as well. Okay. Let's move on to the Sutherland Hodgman polygon clipping algorithm. So in the Sutherland Hodgman polygon clipping algorithm, general procedure is given here, but the key points what you need to keep in mind for writing the algorithm as well as for the numerical, that I will be discussing. Okay. So there are totally 4 cases here. How many cases are there? 4 cases. And if you don't know what is the algorithm about, see, here is some random figure I have drawn. Okay. Now after drawing the random figure, I have to clip it in this way. I just need this figure, what is inside the black square, that only figure I need. The rest of the things I have to clip. Okay. Just as how I clip for the line, I am clipping for the polygon. So how do I achieve that? Firstly, what I will be doing, I will be clipping this part, then I will be clipping this part, then I will be clipping, it is actually LRBT. Okay. So first this part will be clipped, then this part. Okay, sorry, this left, right, bottom, top. Okay, that how we will be doing, I'll tell you now. For that, just these 4 things you have to remember. Either the line will be, if I am considering the point V1 to V2, okay, this is the line V1 V2 and this is the clipping area. I am considering the line V1 V2 of the polygon and the clipping area is this one. If I am coming from V1 to V2, what is inside of this is known as in, and what is outside of this whole thing is known as out. So V1 V2 I am coming from out to in. This is presented out, this is outer area, this is inner area. So I am coming from out to in. When I am coming from out to in, I have to write it as V1 dash V2, V1 dash V2. Okay, V1 dash V2 I'll have to write. If I am presented in to in, V1 V2 is presented in to in, so I'll write it as the second point, which is V2. Okay. If I am present at in to out, if I am going from in to out, at that time I will just write V dash, V1 dash. I will not write V2. In to out, I will just write V1 dash. Out to in, I will write V1 dash V2, both. And if it is both out, I will not write anything. I will just write as none. If you remember these 4 cases, numerical and the algorithm is just a cakewalk for you. Okay. So let's take this example. Okay, in this example, what is given is, this is the clipping area and this is the polygon given to us. So how do we approach this question? I told you the order is LRBT. L, R. First we will consider L. L means, after this the polygon defined, L means I will draw a line here in the left part, and this part will be considered as in, which is inside the polygon, this whole thing. The polygon part, the whole thing till the end, it will be considered as in, and this part will be considered as out. Okay, that's the first thing what you have to keep in mind. After you have drawn a line like this and mentioned what is in, what is out, you have to consider each edges. You will make a table, you will write edges and left clip here, because we are doing left clip. In edges, how many edges you can find? Take it in any order, either this order or you can take it this order. So in this question they have taken this order, so I'll take this order itself. Okay, v1 v3, sorry, they have taken this order, right? So we'll take the same order, v1 v2, v2 v3, v3 v1. After I have written the edges, take each edge and see which case it is lying. v1 v2, as you can see, this is a partition, this whole part is in, this whole part is out. v1 v2 both lie in only, right? So if it is lying in only, I told you have to take the last part, v2. So I'll write here v2, which is the next line. This is the next line, this is in, this is out, and the line considered is this one. So v2 to v3, it is coming from in to out. v2 to v3 is coming from in to out. So if it is in to out, I'll just write v2 dash and mark here v2 dash. See the cases, in to out, in to out, I'm starting for v1, I wrote v1 dash. In to out, I'm starting from v2, I'll write v2 dash. Then this one, v3 to v1, out to in, this is out, this is in. v3 to v1, v3 dash, I'll write v3 dash v1, not just v3 dash. You have to write v3 dash v1 because out to in is, this is also out to in, v1 dash v2 we wrote, like that only, it is out to in, v3 dash v1. That's all what you have to do. After you have written this much, start from v2, read it aloud, v2, v2 dash, v3 dash, v1. Whatever lines you encounter, start from there, v2, start from here, then next is v2 dash, v3 dash, v1, like that. So this is the obtained figure. You have to remove this figure, just have to be remaining with this figure for the next step. So in the next step, as you can see, this is the figure which is remaining. Again you will do the same thing. Now what is the thing is right clip. Right clip means right part of the polygon, this is out, this is in. So since this whole part is in, it will remain same. Whenever the whole part is in, it will remain same. All you have to do is just write v1 v2, you will write v2, v2 v2 dash, v2 dash you will write, v2 dash v3 dash, v3 dash you will write, v3 dash v1, v1 you will write. Same thing, no difference. Then again you will do for the bottom. Bottom means again this will be out, this will be in. Again you will start from here, this will be in out, whatever you have to do that you have to see and write. Out you just have to exclude it, out to in, whatever the points you get here and here, that you have to mark. After that you will be remaining with this one. After the bottom clip, so after the bottom clip you will be remaining with this one where it is mentioned. Yeah, after the bottom clip these 2 points will be remaining, and these 2 points you have to exclude, actually they have still included it. After you have got this one, then the top clip will be done. Since this all is in only, no top clip will be performed and it will remain as such, and the final figure will be like this. Okay, so if you want more information regarding that, you can watch the theory video. They have explained in detail regarding the same problem, so you can watch that. Okay, so here's another problem. Here also you have to do the same thing. This is as in the previous question paper. So here what you have to do, again you have to make the same thing. Consider how many edges are there, AB, BC, CD, DE and EA. You'll write it like this, and you'll consider each edge. First you start from left. Left means this is out, this is in, and this all will be considered as out, and this will be considered as in. And here what are the edges passing? This is in, this is in to out, this is out to in. Based on that you will mark these 2 points, and the final remaining figure will be this much only. Then after that you will perform the right, then you will perform the bottom, then you will perform the left, and the final output will be what is you can see in between the square. So this will be the final output. This question also I had explained in the theory video, you can watch that for more details. Okay, so this is how we perform the polygon clipping algorithm, and also the same numerical also means the algorithm also you have to write in the same way, and the theory regarding that. So basically what we are doing, we are just considering the edges, and then we are seeing which is into in, into out, that 4 cases you have to write. After you have written the cases, you have to you will perform the algorithm in the order LRBT. So whatever the edges are getting off, we are marking it off, and whatever the intersecting points are there, we are marking with new edges, and in the next iteration we are means keeping those edges. If needed, you can use the diagrams as well for explaining the algorithm. Okay, so they'll consider that also for giving marks. Okay, so yeah, that's all what is there in the polygon and the Cohen Sutherland line clipping algorithm, as well as the numerical. A very important question, don't miss it. Okay, so either one you can study, no need to study both. If you have time, study both, it will be better for you. But if you don't have time, either study any of that. Okay, because in the question papers mostly they will ask for or only. Both the line and the polygon can't come in the same place. Okay, So let's move on to the last topic, which is 3D transformation functions, categories and numericals. Okay, so 3D numericals are not as much and just the theory are there. I'll tell you what are the important concepts and which are the important transformations you have to keep in mind. So go to 3D transformations PDF. Also the numericals PDF is there. If you want, you can have a look, because in the previous year papers, none of the previous year papers have asked even a single question regarding the numerical of 3D. 2D numericals have been asked, but 3D numericals have not been asked. So even I am not studying for that, and if you want, you can have a look. So I have anyways uploaded the PDF. Okay, so see here, these are the topics in 3D geometric transformations. Okay, so yeah, these are the topics. How many topics are there? 7 topics are there. Translation. In rotation we have 3 further topics. Then we have scaling. After that we have composite, then other 3 transformation, affine and openGL geometric transformations. The important ones among this is very important ones specifically they have asked is quaternion as well as affine transformation. This they have asked specifically. So at any cost don't miss it. It has a lot of matrix values and all. If you can memorize, you can memorize that one, and if that question comes easily you can score out of out. Okay, so let's get started with the first one, which is 3D translation. So 3-dimensional translation is the same as the 2-dimensional translation, just it will become a 4x4 matrix, because xyz is coming, then 1 is coming. So here also this is the matrix and this is the point. Wherever you have to perform the translation, you will be multiplying this matrix with this one and you will obtain the final points. So for xyz you will obtain some final points after tx, ty, tz transformation, and that is known as 3D translation. Same thing goes for the triangle as well. For the triangle you will have 4 points here. That 4 points you will be translating separately and making a new triangle with the new points. Okay, so that's all basically what is there in the translation, and the inverse translation will be just the minus values here. And rotation I'll cover at last, because rotation is a bit lengthier topic. We'll get done with the remaining topics. So 3D scaling is here. Scaling is also same. Instead of that we'll just have a z value here. Just slight differences are there, not much. So I'll not be focusing much on this these concepts. The same thing, just what we have done in 2D we are doing in 3D. 2D what we have done, transform this into the origin, then scaled it, then again transform back into the original position. That 4 steps. First step, second step, third step, fourth step. And then we have composite 3D transformations to perform 2 or 3 translations together. That is known as composite transformations. That is also mentioned here. And reflection and shearing. These are the matrix values. If you can remember this, it's very helpful for you. That will be helping you to fetch more marks. And affine transformation. In affine transformation, it's an important topic. Okay, here how to remember this formula that I will tell you. Okay, first write x dash, y dash and z dash. Okay, then you have 2 things, x, y and z. X, y, z. Just write x, y, z, x, y, z, x, y, z, x, y, z. The 2 things are a and b. A, just write a here along with x, y and z. What is not with x, y and z? Again write x, y and z. Along with that write b. You understood, right? X dash, y dash, z dash, x, y, z, x, y, z, x, y, z. And along with the x, y, z's you write a, just write a. And here you write x, y, z again and write b along with that. That much you have done. And since this is the x row, you will write ax, ax, ax. Just write ax. Y row, ay, ay, ay. Z row, az, az, az. Again in the order, write along with that x, y, z, and x, y, z. That's all. In that way you will be easily able to remember the equation. This is called affine transformation. In affine transformation, the main thing is it involves the translation, rotation and reflection. It preserves the angle and length as well as the parallel. This is the key concept in the affine. This you have to mention in the answer script. Parallel lines for any of the 3 transformations. Line lengths and angles between the 2 lines remains the same after the transformation. And this is the any of the combination of the phi can be represented in the form of affine transformations. That is another key concept. Okay. And a and b are the constants determined by the transformation type. And x dash, y dash, z dash are the final points. X, y, z is the original points. That's what you have to write in the affine transformation. And here some transformation function: translate f, rotate f, scale f, multiply matrix, and GL load identity, max model, view stack depth, projection, push matrix, pop matrix. Okay, those are the concepts which you have to write in the GL functions. I need not explain much in detail regarding that. So finally we are arrived at the 3D rotation. So listen carefully, in this point we have three types of 3D rotation: 3D coordinate axis rotation, general 3D rotation, and Cotten method for 3D rotation. The last one is the most important one, we'll cover it last. Okay, so first we will get done with these two. 3D coordinate axis rotation. Observe carefully. Here we have how many axes? 3 axes: x axis, y axis, and z axis. If you are seeing it through the z axis rotation, it is called as z axis rotation. From x axis, it is called as x axis rotation. Y axis rotation. And the rotation is happening in anti-clockwise direction by default. Okay, that's the first point you have to keep in mind. And there is 3D coordinate axis rotation. This is the first type of rotation, 3D coordinate axis rotation. If they ask separately, you have to write this one as a separate topic. Okay, so what are you supposed to write in the 3D coordinate axis rotation? Here what you have is the equations. It's starting from z axis. Okay, z axis rotation. There are three types of rotation: along the z axis, along the x axis, along the y axis. Okay, so for the z axis, directly we will write like this. Same the rotation what was there in the previous case, x, y, and z. Here also the x, y, z points, cos theta minus sin theta, cos theta. Just 2 extra zeros here and here, and here 1 0 1 0. Okay, that's all what you have to write for z axis. Now if you have to write for the x axis along and as well as for the y axis, these are the formulas. How to remember these formulas, that I will tell you. Okay, so either you can remember the formula or you can remember the matrix. Okay, because it's in limited time is there, try to remember either one of these. Okay, if you try to remember both, and you can do it, if you can do it, that's more better. But if you cannot do, at least remember either the formula or the matrix values. Okay, so how to remember the matrix values? Observe here carefully: x cos theta, y sin theta, and minus is there, x sin theta, y cos theta. And then what you have to do is, if you have to write for the x axis, it is in the order z x y. Okay, first z, then x, then y. Z x y, keep this in mind, z x y. And looking at z x y, close your eyes, you will get a screenshot in your brain. Okay, z x y. Then to write the value for the x for this one, what you have to do is, you have to shift x to y, y to z, z to x. What I mean is, wherever you can see x, shift that to y. Okay, see here, you have written x cos theta minus y sin theta. Okay, so here what you have to write, y cos theta minus z sin theta, and this one you will be taking it down in the next equation. And here this equation what you will write, instead of x you will write y, instead of y you will write z, and that also you will take as down. Okay, and z was here, that will go as up and it will become x. That's the second part equation. If you did not understand, rewind this video and again listen what I told. Okay, y dash will become y cos theta minus z sin theta, z dash will become y sin theta plus z cos theta, x dash will become x. Again what you have to do, convert y into z and z into x and x into y. So y cos theta, z sin theta, make this as z cos theta and x cos x sin theta, and take it down in the z. So you will get for z, z cos theta minus x sin theta. Same goes for this one, z sin theta plus x cos theta, that will be written down for x1, and then x will be transferred to y, so it will become y here, y dash is equal to y. So that is how I found the trick for the equations, and I myself I am going to remember just the equations, because time is limited. I did not get time to study the matrix values along with the equations. So these are the matrix values. If you get any trick, you can means analyze and keep that in mind. So yeah, there is trick in this also, but I don't like to burden with more patterns and tricks. That will be means you'll get more confused, more probably get confused. So I'm just remembering the equations. Okay, this is the how I'm planning to remember the equations. So that's about the general means 3D coordinate axis rotation. The second one is the general 3D rotation. Okay, so after the matrix value starts the general 3D rotation. In general 3D rotation, same as the 2D ones, but you will have a z axis also. Rotation axis, first you will transform it to the coordinate axis, then you will rotate it, first step, second step, third step. After rotation you will again inverse it back to the original axis. Okay, that's all what is there in the general 3D rotation, and for that you will be using the matrix values, translation, rotation, inverse translation. Okay, so that's the steps also given here, and it's analyzed in depth here for the line. Okay, so that what I showed you is for the object, and this for the line, and the corresponding matrix values are also given. Okay, so you can get more content from here, you can go through it. After that we have the important one, which is the quaternion method for 3D rotation. Few points are there what you have to keep in mind, and if you can memorize the matrix. Let me show you the matrix values. So this is the matrix values, it's quite long, so it's actually hard to remember. I myself am not remembering the matrix values because it will create more confusion. So I'm just remembering the important concepts here and writing that in exam. Okay, so what are the key points I'm going to remember, that I will be telling you. In quaternion method of generation, it is an efficient method. First you have to write it's an efficient method for generating a rotation about the arbitrary selected axis. So whichever axis it is which is not in origin, even in that axis we can directly rotate, instead of transforming that to origin then rotating again inverse translation. To avoid that, it is an efficient method. For that we will be using two things, which is the scalar part and the vector part for the quaternion, s and v. S is scalar, v is vector, and for the scalar it is cos theta by 2, and for the vector it is u sin theta by 2, where u is the unit vector along the selected axis and theta is what is the angle of rotation. So by using these two values and some matrix values, you can perform the rotation. Okay, these are the matrix values and the equations which we will be using to perform the rotation. That's all what I know in the quaternion, but what I'm repeatedly telling, it's an important concept. Also the our faculty have written as 4 stars, so it's actually an important concept. If you get time, practice it, it will be helpful for you if it comes. Okay, and don't forget, this is the final quaternion expression. Now only you can memorize T inverse MRT. T inverse MRT, repeat with me, T inverse MRT, that's all. And whatever you write in the above content, make sure you write this one at the last. Okay, so that's all basically what is there in the module 3, and make sure you hit the like button and subscribe to my channel. That helps me make more videos like this, and thank you so much for watching. I'll see you in the next one.